All right, hi guys. So today we're finishing off lesson 3.3. So last time we kind of started looking at some of the basics of completing the square, and in this lesson we're going to look at how we can apply some of that a little bit more to board problems usually, but more like practical type concepts. So in the first question, we have a sporting goods store sells reusable sports water bottles for $8. At this price, their weekly sales are approximately 100 items. So if you remember from last time, we always want to keep in mind what is the base numbers that we're starting with, and that's what they're currently doing. So those are our base values, right? Is the cost and the number of items sold. So research says that for every $2 increase in price, okay, so now we're looking at what are the changes. So $2 increase in price, then we're going to sell 5 fewer water bottles. So the first thing we want to do is represent this situation with a quadratic function, okay? And so remember that, especially with these types of revenue questions, basically that means you want to know, like the basic formula for revenue is what is the cost of the item times by the number of items sold. So we basically need to come up with a quadratic function to represent each of those things. So in terms of cost, remember, you want to start with your base cost, which was $8. Now, with the price changes, what they're looking at is a $2 increase in price. So for every $2 increase, so that means you can have more than one. So that means we're going to have $8 as our base cost, but we're going to add a $2 change times by however many number of times they change the cost. The other thing we need to know is how many are sold. Okay, and so for that, our base value was 100 items, right? But for every one of these increases that's represented by X, they're going to sell 5 fewer water bottles. So fewer means we need to subtract off. So if they started with 100, if they do one $2 increase, it would be -5. If they do 2, it would be -10. So basically what we're looking at here is 100 minus 5 times by the number of increases that they do. Okay, so now we can write our quadratic function. So revenue is going to be equal to the cost, 8 plus 2x, multiplied by the number that are sold, so 100 minus 5x. Okay. Then remember the next thing that we want to do is to multiply that out. So it's going to be Rx, and remember you have to make sure that you multiply everything in the brackets. So an easy way to keep track of that is FOIL. So you multiply the first two items, so 8 times 100 is 800, and then you do the outside items, so 8 times by -5 is -40x. And then you do the inside, so 2 times by 100 is plus 200x. And then you do the last, so plus 2x times -5x gives us -10x squared. So don't forget to multiply the variable as well. And now the last thing we can do so that we have the most simplified version of our quadratic function is we can combine the two like terms, which are both multiplied by x. And the other thing is, remember, if we want it to be a proper quadratic function, we want to have the x squared value first, then the x value, and then just the number value. So our first value here, remember always to keep the positive or negative together with the value. So we have -10x squared. Okay, and then -40x plus 200x is plus 160x. Okay, and then 800, there's no negative in front of it, so we can do plus 800. Okay, and so that's our revenue function. Now the next thing it wants us to do is determine the maximum revenue the manager can expect based on these estimates. So basically, in order to figure out maximum revenue, remember from last time, anytime you're looking for a maximum, you want to determine the vertex, okay? And so when we are given a quadratic function in the standard form, we need to convert it. And we went through all of those steps last week. So remember, if we start out, I'm going to change this Rx to Y just for simplicities. So we're starting out with this is our quadratic function. The very first step we need to do is group together the first two values. So negative 10x squared plus 160x plus 800 is going to go outside of the brackets because we want to keep these two together. Now remember, if we have a number value in front of x that isn't equal to 1, we need to try and factor it out. So essentially that means we need to divide everything in these brackets by this value to move it out so that we only have a 1 in front of the x. So negative 10 divided by negative 10 will give us 1, so we need to bump negative 10 outside the brackets. That's going to leave us with x squared plus, if we do plus 160 divided by negative 10, then we get, negative 16. Sorry, I wrote in that positive too fast. So minus 16x, okay, and then plus 800. Okay, so we factored out our negative 10. Now remember, the next thing we want to do is try and make this into a perfect square trinomial. And the way that we can do that is by finding what is half of this value. So half of negative 16 is negative 8, and then we have to square it. So negative 8 squared is positive 64. So now we can say y is equal to negative 10 x squared minus 16x, and then remember you want to add the 64 that we just calculated because that's going to complete our trinomial, but because we can't just add a number into an equation, we need to balance it out by subtracting off the same value. Okay, and then plus 800 outside the bracket stays the same. Now these two numbers are both being multiplied by negative 10. So remember, the next thing we want to do is to be able to move this value outside of the brackets, but this value has to be multiplied by negative 10 before you do that. So our next step is going to be y equals negative 10x squared minus 16x plus 64. Bracket negative 10 times by negative 64 is plus 640. And then plus 800. Okay, now if you remember near the end of the last lesson, I mentioned how you can simplify steps. So what we want to do here is make this into a binomial. And remember, the way we can do that is basically to figure out what is the square root of 64. Well, it's positive or negative 8. So 2 times by what value will give us negative 16? Well, it has to be negative 8 to get to negative 16, right? And so now we can say y is equal to negative 10 x minus 8, right? Because that's what we just figured out it would have to be, squared. And then plus 640 plus 800, which gives us 1440. Okay, so now that we have our values in standard form, what is the maximum revenue they can expect? So remember, this here is our p-value, or our x-coordinate of the vertex, and this is our q-value, or our y-coordinate of the vertex. And the y-coordinate is going to give us our revenue, so we can say maximum revenue is 1440. Oops, 1440. And it asks you what selling price will give that maximum revenue. So remember, when you have this in the bracket with the x, the negative is going to be the opposite for the actual value. So selling price is obviously not negative $8, but it'll be positive $8. Okay, so the original price that they actually had it at would have been the best price. Now, how do you verify this solution? Well, you can go ahead and enter in your formula. Or sorry, you don't want to do this one because otherwise you're just verifying this. So when you verify the solution, always make sure that you verify your original equation so that you can make sure that these points that you got in your factoring and everything are correct. So if you enter this into your calculator, then you should get a graph that looks, and I'm not going to go through all the graphing again here, but it should look, and of course you'll have to adjust your windows because these are not going to fit into the standard range. But your graph's going to look something like this, and the point that you're going to get is going to be 8 and 1440. Okay, and so then you can say, like, here the vertex confirms our solution. So like I've mentioned in previous lessons, just make sure to refer to the posted filled in notes if you're concerned about like knowing how I would kind of expect to see the solution on a test, because I would expect you to mention that your graphing confirms what you found in your calculations. Okay, the last part, explain any assumptions you made in using a quadratic function of this situation. Now, the big thing when we're dealing with revenue of the assumptions that we're making is basically that we're kind of really simplifying things. So we're assuming that the price of the water bottles is going to affect the numbers sold and that not much else is going to affect it, right? So we're not taking into account other factors like, I don't know, maybe in the wintertime people just don't buy as many water bottles or, you know, things like that. Okay, so we're kind of oversimplifying what's happening in reality. Okay, let's look at one more example. So Adrian's saltwater candy booth is beside Courtney's mini donut stand at the carnival. Adrian has determined that if he raises the price of his candy by 25 cents per bag, he will sell 25 fewer bags each day. So again, thinking about where is he at. So Adrian currently sells 300 bags. So this is the current setup at $5.50 per bag. And the change that he's looking at is raising the price by 25 cents per bag. And the change that will happen to the number sold is that he'll sell 25 fewer bags at that change. So how much should Adrian charge to generate the maximum revenue for per day? So the first thing is you need to determine your revenue function. So we want to figure out what is our cost. So starting at the original cost was $5.50, so 5.5, and he's looking at raising the price by 25 cents per bag. So plus 0.25, and remember that's always going to be multiplied by however many times he raises the price, so it's going to be 0.25x. The other thing we're going to have here is the number sold, and his base value was 300. And what's going to happen with each increase? He's going to sell 25 fewer, so minus 25 bags times by however many increases he does. Okay, so now we have our basic kind of two components for the function. So now we just want to write it out. So Rx is going to be equal to 5.5 plus 0.25x. Oops. Put my bracket on the wrong side there. Plus 0.25x. And then we want to multiply that by 300 minus 25x. Okay, then I want to expand it. So I'm going to multiply everything out. First times by first gives me 1650. Outside, 5.5 times by negative 25 gives me negative 137.5x. Inside, 0.25 times by 300 gives me positive 75x. And last is 0.25x times by negative 25, which gives me negative 6.25x squared. Okay, and then for my last step, I just want to basically combine the two x values and rearrange so that my formula is in the proper format for a quadratic, which means the x squared is going to be first. So it's going to be negative 6.25x squared, and then negative 137.5 plus 75 gives me negative 62.5x. And then this one was a positive value, right? Because there's no negative in front of it, so plus 1650. And there's my quadratic function. Now, if we want to figure out how much revenue he's going to make, we need to convert that into vertex form. So remember, we're basically going to group the first two items together to start. So Rx equals negative 6.25x squared minus 62.5x plus 1650. Then we want to make sure that we've factored out the value that is changing the x squared value. So divide out negative 6.25. And we're left with x squared. Negative 62.5 divided by negative 6.25 gives us positive 10x. And then plus 1650. And then remember we need to try to make this into a trinomial. So half of 10 is 5. If we square 5, we get 25. So we're going to have Rx equals negative 6.25 x squared plus 10x plus, so we just figured out half of 10 is 5, squared is 25, so plus 25. But then remember we need to balance that out by taking off 25 so that we're not adding any number value overall. Plus 25 minus 25, close the bracket, plus 1650 that we had at the end there. Okay, now the other thing we want to do now is move this value outside of the brackets, but remember because it's being multiplied by this, we need to take that into account. So Rx equals negative 6.25 x squared plus 10x plus 25. Negative 25 times by negative 62 or 6.25 is going to be equal to positive 156.25 plus 1650. Okay, now in our last step we want to make our trinomial into a binomial. So essentially we need to think about what is the square root of 25. Well, it's 5, and 2 multiplied by 5 would, what version of 5 would give us positive 10? Positive or negative? Well, it has to be positive, right? So now we can say Rx is equal to negative 6.25 times by x plus 5, right, to give us our positive 10. Square the bracket. And then plus 156 plus 1650 gives us plus 1806.25. Okay, so now we have our vertex form, and because the question is how much should he charge to generate maximum revenue per day, well, we just found out that our value needs to be 5, and that will give us a maximum revenue of 1806. Okay, so if you were doing this on a test, I would expect you to say he should charge $5 per bag, which will give him a maximum revenue of 1806.25, and then say like whether or not, so you should always confirm by graphing, right? So you would go back to your original quadratic in standard form, put it in your graphing calculator, and just write in, you know, these coordinates were confirmed by graphing. Okay, all right, so you guys have some practice problems to do, and that is it for chapter 3. So good job, and I will see you in the next lesson.